Alrighty, we're going to do as it says right here in my tutorial, which is we're going to practice using Docker containers to interact with a MySQL database running in AWS's RDS. Everything is going to be created and run in AWS. So here are our list of things that we're going to do. Run Docker container, starting from an existing image in Docker Hub. We're going to update it with customized software code that's going to have Node in it. You don't have to have knowledge of Node to be able to do this tutorial. But at the end of this, you'll know something useful, which is how to have like running code that does something, a very basic website that interacts with the database, and everything is hosted in AWS. We're going to interact with RDS from a container, and then we're going to save our container as an image so that we could spawn unlimited copies of that image if we needed a cluster of a particular application, and all of them interact with a particular database on the back end. Um, as I'm saying all those things, I'm thinking that we're not going to do everything perfectly like you would do in a production setting. I'm going to simplify some things with the purpose of just teaching about Docker, not necessarily good coding practices like embedding your credentials for your database right in your software code. But I really just want us to be able to see how the process of updating a Docker container works and then saving it back out again. All right, so the context for this is imagine that your donut company has 33,000 locations across the world, and they have an old timekeeping system so that people could clock in, clock out at each store. So the idea of who the person is, which store that they work at, those are some of like relevant items. And this fictitious story says they used to have like maybe a US based timekeeping system, and now they think, hey, we need something that's going to be a little bit more complicated. And so let's start it from scratch. Now, this isn't the end all be all final product, but this is just the first round of tracking people's time. And so we'll create some data storage that would relate to keeping track of people's time at a particular store. Again, the goal here is just to learn about containers, not so much about writing any particular software. All right, here is an image of what we're doing. So we take something from Docker Hub, an image, and we're going to use the Node image because that's already basically has the pre-installed runtime for running Node, which is a popular runtime for using JavaScript like code to do programming with on the server side. We're going to write our code, add it to a container that we're running from that image. And then after we've got like a cool container working with an application on it, we're going to save it back out so it's inert and not actively running. It's just an image. But we know that it can talk to a database when it's running. And so we're going to take that image and then show that we can spawn multiple copies of that image that can talk with a MySQL database. It feels like about half of this lab is setting up the database, so let's go ahead and get started. Here's a highlight. It says, well, if you've been doing this stuff a lot, create a MySQL database with in RDS in the region that you plan to work in a new VPC with these fields and settings associated with them, and then put in some data that looks like that. So that's the high level description. And then here's a longer description of how you would do that so you can follow along with me. So I'm going to look for RDS, and I will work in the Virginia region today. I don't know that it necessarily matters. I'm going to click Create Database. I'm going to select MySQL. And the reason why I'm going to pick some certain ones here is I want us to be able to use the cheapest instances possible for this tutorial, not necessarily what you want to do if you're doing production. But going to go down to Dev Test. We're going to make a single instance as opposed to one that has some reliability and is running in multiple places. I'm going to call this the database, the time card system. I guess I didn't say that up above. Um, admin. This would be a cool way to do it with Secrets Manager, but we'll just sort of make this a little easier, I hope. Um, I'm going to use a super secret password, which may or may not be password one. But if you want to hack me later, this will be down by the time you see this video, so it won't matter. Um, and then we're going to come down here to burstable classes, and we can use t3.micro. That's just fine. Under storage, we don't need 200 gigabytes of stuff. 200 is overkill as it is. Let's see. I don't think we need anything else. Under connectivity, we are going to create a new VPC because this, for me, makes things a little bit easier. And we want it to have public access because we need to connect to it. I have MySQL Workbench downloaded. I won't be able to access my RDS instance if I don't make it publicly accessible. So let's see, I'm going to create a firewall. So we need to think about the access that we're going to be providing to the database. It's going to need access both from the computer that I'm working on right now, as well as later on the containers that are up in the cloud. By default, when you launch RDS, it picks up your development computer's IP address at your house. It's not going to know necessarily what the future IP addresses are of instances that run containers later on. So we'll have to update our firewall at some point. I'll call this firewall rule that's going to be placed around that database instance. I'll call it database SG for security group. Don't really care where I put it. And with, I think everything else should be fine. Lots of other options. Now, I think that I have you use this database for the second lab as well. So just keep in mind that if you do the two labs as close together as possible, it'll minimize your costs. For me right now, this costs 14.71 a month or about 50 cents a day. So as long as I get it done within the next few days, I don't really care. So just watch that. Now, it can take a little while to create the database, notably here, 2 to 10 minutes. So because of that, I'm gonna go ahead and hit pause on this video and then come back when it looks like things are, well, when it says available. Like right now it says creating. So when that happens, I'll come back. All right, after a short power nap on my couch in 5 to 10 minutes that has gone by, this thing says it's been successfully created and it says available. At this point, I want to just make note of what its IP address is or its URL. So one of the ways I could do that is I could click on this link, come down here under connectivity and security, click on endpoints, and there is the URL. I'm going to go ahead and save that in another document. So a couple times here, I'm going to need some information. And so I'm just going to use a notes document to keep track of some things that I'll be using throughout this. And I note also that it's publicly accessible, so this will be a good thing. All right, um, now we need to create our database. Now there's a security group rule here, and if I want to, I could check it and verify that it's allowing traffic in from my personal computer's address. I'm sure that's the case. That's the default. If we get an error message later on, we'll sort that out. Okay, so I have downloaded MySQL Workbench, and I've probably got a bunch of old connections here that I should get rid of. Let's see if I can I delete this one? Delete you. Yes, goodbye. All right, let me go ahead and, oh, this one. Actually, this is maybe the one I should use. These ones are all dead. So just so I start with a relatively clean slate, I'm going to click the plus sign, and then just like it says over there on the right, I will call this connection the time card, DB connection, although the name doesn't matter. I'm going to need the endpoint that I have right here. That's also in the window right behind it as the place that I'm trying to connect to. And ooh, actually, that's bad. It added in an additional character there that definitely would have broken things. And let's go to the end, and no, that's bad too. That was a terrible copy paste, I suppose. Oh man. All right, well, let me hopefully I got all the special characters deleted off of there. Okay, the default username is admin for this, and let me go ahead and click test the connection, and it's prompting me for a password, so that means it got through the firewall in order to present me with that challenge. I will type in my super secret password that may or may not be password one, and incompatible, blah blah blah. I don't know what that's about. Blah, 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 blah. Okay. Anyway, it's connected. All right, and then I'm going to double click on there and open it up. And now we're ready to do some business. So let's go ahead and we're going to, in schemas, create a new schema, and we're going to call it time card. So basically so right clicking over here, create schema, we will call it time card. So this is basically our database that we're going to call time card, and we'll have tables associated with it. So I'll click apply, and it has been done. It's over here. Great. Next thing we're going to do is create a table, and we will call it employees. So, and this is where we're going to limit ourselves to in terms of the database stuff that we're creating. We'll call this employees. Oops. So of course we could make this a lot more complicated, but really we just care about the containers that are interacting with this. So there it is, names, employees, and let's go ahead and start adding some things. So ID, and it will be primary key, and auto increment. We will have a first name, not null, la last name, not null, and then what's the store that they're working in. And that one will also be not null. All right, I'm going to double check, make sure everything looks identical to what we have over here. Always don't forget that. And then I'll click apply, and close. And then now I'm going to expand this. One of the easiest ways to add data here is to just right click, select all the rows, and then down here start typing things in. So time to do some entries. Dave Smith in store 52. Um, Sally Smith 52. So they're related. Perhaps they bought a franchise. Tyler Smith 53 must be a brother. Um, Joseph Steed, a former student. Warren Danes, 55. All right, and so with that, I can click apply. It's going to do the inserts. Auto increment is there, so it should give me my IDs, and we now have a database. So with that, I can go ahead and just close this thing because I don't need to interact with this anymore. Okay, so the next thing I need to do is create effectively a development machine. Now, I could do all this stuff on my local machine, but and technically everything it already is installed for Docker locally. But just in case you don't do Docker all the time, let's just go ahead and put Docker on another computer that we're going to use temporarily and discard. So that's why we will call it a development machine. So so just like you could set up your local Windows machine or your Mac as a development machine, we can do the same thing with a random EC2 instance in the cloud. So I'm going to click Launch Instance. I will call it Dev Machine. Uh, I need I'll take the defaults. I'm gonna say no key pair because we will do the instance connect method in the browser. And then I'm going to create a new security group. And, oh, wait. First, though, I need to check the network, and I'm going to put the I'm going to put this EC2 instance in the same network as the one that I just created. But do I know what I just created? No. All right, so I got to look this up. All right, so find my AWS console again in another window and find my RDS. And here's my instance, and I'm going to click on it and let's see if I can find that VPC. So the VPC ends in 11E4. So just in case I need to refer to that later on, I will make note of that. Okay, so now I'll go back to the other tab again, and I want to put this E2 instance in 11E4, and I want to create a new security group. I will call it, um, do I need a special name for this? It says call it anything you want. I will call this the Dev Machine Security Group. That's fine. The things I need on there are port 22, that's already there, coming from anywhere. I'm going to need port 80 based on the stuff that I'm doing. So find HTTP and I'll say from anywhere IPv4. I'm going to do custom from port 8080. Now there's a couple ways I could do this. I could do two separate ones. Um, I'll do that just to show that I could. Another option I can do, so here's 8081, is I could just do a range. So I might update it later, which I know I will do in one of these labs, but for now I'll just do two separate ones to show that that's a perhaps less efficient way to do it. All right, so I've got 2280, 80, 80, and 8081, and we are ready to go. So I'm going to click launch. EC2 virtual machines launch so fast these days. I'm going to click on this link. I'm going to click on connect. Even though it's fast, I feel like I should give it a couple of seconds to try to do any um, startup stuff that it's doing on the back end. I'm going to click connect here under EC2 Instance Connect. And I'll run an update command first, sudo yum update, yes. And sometimes it does updates and sometimes it doesn't. So long, awkward pause. Hopefully you're typing the same thing. Sigh. Okay. Sometimes it takes a little longer than others. That was about 20 seconds or so. All right, let's install Docker now. So sudo super user do yum install Docker, yes. Taking a second, but it'll be there soon. Just hanging out. There's a song so tired of waiting, waiting for you. Ooh, ooh. All right, it's like I think it's an old-fashioned one. All right, now we need to start that. So super user do service Docker start, and then super user do. We're gonna modify user, modify, add to the group Docker EC2 user. I don't know if I want to go too into depth on that. Just in EC2, it helps. And then in order to get all these, at least that last one picked up, I need to exit. So basically EC2, the user that you're logged in as right now, you need it to have a little bit of additional permissions for interacting with files and processes associated with the Docker. I think it's probably got its own user and group. And so we need to have your user added to that so it can do Docker stuff. All right, let me hit click connect again. In we go. All right, sweet. All right, now we get to have some fun because now we're set up. So first off, we're going to see if there's any Docker images that are installed here. So we do Docker images. So Docker image is like a light version of, well, it can start off as a light version of Linux, and then you install anything you want on there. So you could, it sort of acts like a virtual machine. So you can install databases, you can install all kinds of stuff on here, just like you would Linux. And then you can save it as an image. And then if you want to start another container, you start it from an image. There's no downloaded images here, so there's nothing to run on this computer currently that is Docker related. Now, what we can do is we can pull down the latest version of Linux with Node installed on it, and we can do that by typing Docker pull Node. It's kind of got fun ways of characterizing what it's retrieving. Okay, and it says it pulled down a version of a node image tagged latest. There's actually a lot of versions of node that get released over time. And by default, if you don't specify the tag for which version you want, it by default pulls colon latest, even though we didn't write colon latest up there. So now if I type in Docker images, I can see that I just used up 1.13 gigs on my hard drive on my EC2 instance. And I don't know if you can see it perfectly there. I know on my computer it's hidden a little bit. So maybe I'll just drag it over a little bit. Okay, it says I've pulled down a image um, node with a tag latest. Technically, both parts of those I think are the tag, but whatever. Um, if I ask you if you're doing this as an assignment, how many images are currently listed? And the answer would be one. And just to show that there's different versions of them, I've gone out and looked up stuff before. There's an awful lot of them, but I can grab something. Docker poll, Node version 17, and I think we're probably on at least 25 right now. Hold on, let me turn on my motion sensor. There we go. Node 17, Alpine 3.2. Alpine is a relatively lightweight Linux version upon which people oftentimes put software. So anyway, they built on Alpine to do a particular version of Node. And if I do this, it's going to pull that down. I do Docker images again, and now I can see that there is a secondary one that exists on the computer. All right. And if we're trying to keep things tidy, and when you're experimenting, especially if you're on your local computer, you can fill up your hard drive because, you try 10 different Docker containers and suddenly you just used up 10 gig or well, 10 different Docker images and you just used up like, 10, 20 gigs of space on your hard drive and you're wondering what's happened. It's a little funner to do on EC2 because we can just throw this thing away later on. But in case you're working on your local computer, you want to do stuff like Docker image remove and then do the type in that whole name, node 17 Alpine 3.12. All right, so now if I do Docker images, whoops, Docker images, Docker images, you can see that there's only one thing left there now. Okay, let's just learn a little bit more about these images that we're pulling down. If we go to hub.docker.com, there's a search bar at the top. Technically, there's millions of things. So if you wanted to search for Node, if you wanted to search for MySQL, if you wanted to search for Postgres, if you wanted to search for, um, anyway, just about any programming language that you can think of, or sometimes a combination of things like a whole LAMP stack, if you want it pre-configured with Linux, Apache, MySQL, PHP, MongoDB, any combination you can imagine. There are typically a version of Linux, sorry, of there's an image, a container image out there that has that on it, and that is actually how a lot of professional developers do their work. And this is the thing to know how to do. Although if you're just starting off in school, you're just grateful to know how to program in C sharp or Node or whatever. And then these higher level things of how do you actually do development in the real world are not your primary concern. But this is uh, the key way that you should think about doing your development. So if I type in Node as an example and I hit return, it brings up a bunch of images that match that search term. So we have different providers of a node image. This one with the award symbol on it is an official image from the Docker Foundation or whatever the organization is that upkeeps this. So if I click on it, it tells me again that this is the official image for this particular technology. And then oftentimes there's two different things you'll see. Either you'll see the full documentation on how to use it on this page, or you'll see a link to another page that shows you how to do it. So those are the kind of the two common things you see. Up here at the top, remember how we were doing Docker poll and getting different images? So for just Node version 25, as of today, here's like all the different versions that have different attributes that you could use. And I guess you could go backwards a little bit down to um, 20. So you might build your application on a particular version of Node, and so you would need to reference the version that you were using in order for your code to be compatible when you're running it in the future in Docker containers. So you got lots of options. You could click on the link down here, which would tell you how to use it. And we won't get into that today, but oftentimes, well, one of the key things you need to do is you need to learn how to use a Docker file with this, typically so that you can take maybe some code from a code repository and put a whole bunch of it into a raw brand new container that you spin up from this image and then save it back out again. That's a little bit more complicated than we're going to get to today, but we will get to that in another video. All right, so if we were to look over the documentation, it would tell us that in order to use this, we could type in Docker run node, and it did something, it hung for a moment, and now we're back at the command line. So one of the things we can do is use the program or the command docker ps, and that says show me the processes of type Docker that are running. And we see a bunch of column headers here, but there's actually no entries underneath it, so there's nothing running. There's another command we can do like docker ps-a, and that'll show us things that are currently running as well as things that were running. And if we do that, we see that there was a container of type node or image type node that was running and it exited 31 seconds ago. So interestingly, our run command started it and then it turned itself off automatically. And these were some of the features of it when it ran. Let's see. Whenever you run it, you can, with the run command, you can specify a name for that particular container while it's running. Or if you don't do that, then it always gives it a made up name, which is oftentimes a like an adjective combined with the name of somebody really famous from the world of computing. So I don't know who Capizza is. I guess that's bad. But usually it's like super famous. So if I typed in Capizza, it'll be some rock star from the world of computer science. Um, so one of the reasons why we have this name is so that when we interact with our containers, we can either use this name to interact with it, or we can use this thing that says container ID to interact with it. Either one. All right. Let's go ahead and start one up in a way that doesn't stop. So we'll do Docker run terminal interactive, so attached to the terminal, and I will give it a name this time rather than letting it make up one, and I'll call it my node container, and it will be, and which image am I going to run it from? Node. All right, so notice it dropped me into a, oh, what do they call it? The REPL, that's right. So this is basically like if you had Node installed on your computer or any programming language, you can usually just drop into the the terminal way of interacting with that programming language and just do commands one at a time. So with this, I could do things like 1+1, and I could do so this is, JavaScript slash node, console.log hello world, and I hit return, and it does hello world back out to the command line. Now, to get back out of this, we hit Control C twice, and now I'm back to my EC2 instance. If I do Docker PS, again, it is gone. Well, so what happened was when I ran that, it actually started the container, and then I was interacting with it as if it was a whole brand new computer virtual machine, even though it's more of a lightweight virtual machine. And then when I exited out of it, it turned it off again. So that's interesting that you can have a temporary use computer, but if you want to have like a website running, we need to have a way to make sure this thing stays on after we've done a command like run. So we'll get to that soon. If I type docker ps-a, we can see that it exited about 43 seconds ago, the one that I gave this particular name to, and this is the previous one that we were working with. All right, so let's go ahead and try this again. And to make it stick around, we're going to add in this -d command, which means run it in detached mode. So Docker run detached interactive terminal is going to be available. Name my second container, and it's going to be of type node, and it spits out the identifier for this container. And if I type in Docker PS, it actually shows me the first, I don't know, 12 or so characters of that string. And then it also, anyway, you can see that it's actually running this time because I ran it with the detached command. So it's still up and running. It's been up for 7 seconds. I gave it a formal name. I can refer to it and interact with it if I need to do things to it using either this identifier or this identifier, both of which are unique. Um, this is actually the full ID of the container that was generated spontaneously, and this is a shortened version that I can use to refer to that longer version of the container name. All right. Let's go ahead and interact with it. So in order to interact with a running container and interact with it from the command line, I'm going to type docker exec, like execute, terminal interactive, my second container, which is the name of it. And then this is weird because it's already started. We don't need to say, hey, start a node container. It's running. What we do have to do is say, hey, when we connect to it, like what's the program that we want to run to interact with it? And we're going to use bash. So, so what just happened is you saw my cursor change from EC2 user at my AWS machine. Now it says root at. Basically, I'm now the user root operating from the command line in the container. So as you think of a series of layers here, there is a computer that you're logged into, and it says and you're the user root on that container, that Linux machine. If you log out of that, the EC2 instance is still there underneath it. But right now we're interacting directly with the container that's running on that EC2 instance. So we could do things, let's see, PS, there we go. It tells you what processes are running on there. Um, okay, so we have a command line system. We could do stuff with it, but we won't. So I'll hit exit, and I'll do Docker PS, and we can see that it's still up and running because of the way that we started it. And let's see what my next idea was. Oh, I was going to note that we connected to it using this name right here, its formal name, but just to show this as a proof of concept, I can use uh, even just a subset of the actual container ID, and it will log me into it. So that's just like a little trick that you can use. I'm going to log back out. Good to go. And let's see. So I'll do Docker PS one more time, and we can see that it's running, and we can technically stop this container now that's running in detached mode. If we do Docker stop, my second container. Takes it a second to think about it. Seems like a simple enough idea. I don't know why it has to think about it. Okay, and now if I do Docker PS, there are no running ones. But if I do Docker PS hyphen A, I can see that it is now in the list of ones that aren't running anymore. And technically, once something is in this stopped state, what I can do is I can actually start it again by doing Docker start and then either the container ID or the name. So it's still technically using up resources on my machine. If it has something in its virtual hard drive, if I created some files in that container, if I restart it and connect to it, those files will still be there. So in the grand scheme of doing development with containers, containers that you've stopped using are using up resources on your computer, and you do want to delete them just like you delete images. But we won't worry about that for now. But just know that they're still around. I could use them even though I've stopped them. All right. So think about it like maybe like you bought a car and you started the car and you stopped the car and it's sitting in your driveway. You could start it again if you want to. And if you don't want it, at some point you better get that thing off your lawn because that's going to be a lot of cars at some point. All right, let's go ahead and do something a little bit different. Um, what we would like to do is be able to use these things as websites. And in order to use them as websites, there needs to be a way to connect your Docker container to the outside world in some way. Um, so we'll probably talk more about that later. So let's go ahead and just like do a command, Docker run detached interactive terminal. And this time I'm going to say port. And I'm going to say, and the thing on the left is a port on the EC2 instance, or if you later on run this on your local computer, if you're using Docker desktop, the thing on the left is the port on what we would call the host machine. So if I know the IP address of my EC2 instance, I could do that IP address colon and then this port, and then it's gonna create like a little connection, redirect it through networking straight through to this particular container. And so what this is saying is that if my container has a program running on port 3000 on it, anytime people on the EC2 instance visit 8080, it's going to networking wise direct us right around that EC2 instance and right straight to the Docker container and try to talk to it on port 3000. So I type that, it's running, and I do Docker PS, and now I see some additional information about ports. There we go. And so I have a little sample here. So let's just say that my EC2 instance IP address was this. If I do colon 8080, it will go straight to the container on there. So if I'm running a website on port 3000 on my container, then this IP address with the port will take me there. And interestingly, I can do this lots of times. I can say, hey, create me another one on port 8081 and another one on port 8082. So if I ran from scratch these three commands, it would create three separate containers that would be actively running on my computer. So if you think of it like a cluster, then if I had a load balancer, I could say, hey, load balancer, when somebody visits my IP address, equally distribute them among all of these three containers that are there. I don't think I'm going to do that exactly right now, but that's the high level idea. So we don't want to just like make a single container. We want to have like a cluster of containers, but we also have to have a way to reach the stuff that's running on the container. And this port pair mechanism is the way that we interact with stuff running in a container from what I would call the outside world. All right, let's go ahead and attach to our container that's running. And we will do that by saying Docker exec 887CB, and then we are going to attach with bash. Okay, nope, I did not do that right. I think I'm supposed to do Um, let's see. I gotta connect to the terminal. So even I forget this, especially if I haven't slept well. Okay, so I just needed to add the terminal interactive there. All right, so now we're connected to a running one. And now we can start building out an application. So if you're oftentimes writing an application from scratch, you will download and install Node or Python or C Sharp or whatever. We're starting with a Node container with the very latest version of Node so that we don't have to worry about installing Node on a computer. All right, so with that, we can now start building out an application. This is our time card. So you don't need to necessarily memorize any of the code here, just follow the steps and understand that when we put code on here, it runs and we didn't have to install the runtime. So this is just kind of fun if you happen to be a fan of Node. If not, just follow along. So I will make a folder where my application will be built, and I will go into that folder and I will now type in npm init to start scaffolding out a brand new application. So we're going completely from scratch here. So I'm going to accept all of the defaults, type yes, type ls, and now there's a package.json, which is the starting point for building an application. Now I'm going to install a couple of libraries or packages that will assist me in writing a usable web application that displays web pages as well as interacts with the database. So first I will install the web framework Express, npm install express. The next one I will do is npm install connects, which is like the word connect, and it's related to databases. npm install connects. And I know that the database that I'm going to be interacting with is of a particular variety. It's MySQL today. My npm install MySQL then. And now we should be in good shape. Okay, so let's go ahead and create our first. I'll just note what's in here right now. So this is just stuff here's my folder full of libraries that I just downloaded related to my installs. And then my basically project configuration file package.json. Now we're going to start writing out actual code files. So I'll say nano index.js so that you have, oops, and it says you do not have nano installed. Okay, so notice that we are on our container. And containers, one of the nice things about them from a security perspective is they have almost nothing installed on them that you usually have when, in contrast, you use like an EC2 instance. It's got like all the default programs on there. But a lot of the programs are not installed on a container, and that makes them more lightweight. So we need to install even just a code editor, a text editor here. So I can do apt get install nano. What have I done? Okay, and it didn't know anything about that. So first I have to update the catalog of known programs that we can install. Apt get update. So now we have a catalog of that. I'm going to click up twice, and now I'm going to say install nano now that you know that it exists. And off it goes. And so now I can type nano index.js. So this is the file I'm going to start programming with. All right, I am going to copy and paste this code right here. And all it's going to do is do hello world. So the key part here is response.send and then that text. And I'm going to say run this application on port 3000. So, and that's default for Node. All right, so the next thing so you do Control O and Control X, and then we start this thing by typing node uh, index.js. All right, and let me look at my EC2 instance. This is the IP address that I had generated for my EC2 instance. So if I were to type this and just try to hit port 80, the firewall rule is open, but nothing's going to happen. But if I do colon 8080, then something good happened. So it hit, so basically on the EC2 instance, it said, oh, I know what I'm supposed to do. I have Docker installed. And Docker is telling me right now that when something visits on 8080, I'm supposed to redirect that traffic to a container called 87CB and talk to it on port 3000. So that's a lot of magic happening by typing in that. Okay. Now I said, let's think about so one of the things I'd note here is that we've written some code, and wouldn't it be nice if we could like freeze this container and then spawn lots of copies of it? So I know that and I'm gonna hit Control C. And I will type in cat and index.js. Here's the contents of our file. It's not a very big program, but if we wanted to have like 1,000 containers all running this program, then the method we just used would require us to log into each one manually and put this code on there, which is not a great way to do it. The overall idea is you make a working container just the way you want. You freeze it as an image, and then you spawn unlimited copies of that, but just using them on different ports with that Docker run and the -p command. So before we get there, let's go ahead and update our code a little bit. So here is um, a more advanced version of this application, and this one has some database connectivity in it. So just go ahead and copy this, copy, and go back to Nano, and I forget. There's a marker. Let's see. There's a marker command and then something else to do multi-line cut. Sorry, I don't have it memorized. I know it says MA right there. There's a way to do this, and I don't have it memorized. I'm actually a VI person myself because I'm old school. So I just deleted all this. I'm gonna hit paste. All right. And so what this thing does is down here on the app.get, it says if somebody visits the web page without any folders mentioned, then run the connect program and basically talk to the database and do a select everything from the employees table, and then with the what's effectively like a an array result, a JSON result of the data pulled back from the database. Do a response.send, just spit out that ugly JSON, which is select everything from employees back out to the web browser. But before that, we have to configure connects and say, hey, we've got a URL we need to visit. We need to give it a username and a password, connect on 3306. Anyway, a lot of stuff. So one of the things I need to update up here for me is this is one of the earlier versions of an RDS instance that I used, and it's not the one that I have right now. So replace this with your, let's see, do. All right. Oh, it's over here still. Okay, I just needed to find a window somewhere. I'm actually going to copy and paste from here. I don't want any HTTP or HTTPS in front of it. I just want that, just the URL. So I come over to here and I paste it. There's no spaces in there. We're in good shape. And then I'm going to update this. EASSWORD1 is what I'm using. And with that, I'm now ready to see if this works. So the idea is there's a container running on my EC2 instance, and when this code runs, I want it to go out and talk to another machine that's basically at this URL slash a different IP address somewhere on the web. So I do Control O, and I do Control X, and then I do node index.js to start that program. And initially, there are no errors. But if I go to actually visit the web page with the updated stuff, it's going to try and connect to the database. And even though the URL is correct, and even though the username and password is correct, at some point, well, it's going to die out. And if I come over here to where I ran it, it threw an error message and it says timed out. So When you see that kind of message, it indicates, hey, there was a problem connecting to the database somehow. And in this case, if you recall what I said we did was when we set up RDS, it by default had an incoming firewall rule from our development computer, but it doesn't know anything. It didn't know anything about this EC2 instance at the time, and so we need to allow in traffic from here. Um, so this is just some thinking that you can do ahead of time. When you're allowing inbound traffic to a database, you can, on the one hand, set an IP address if you know the IP address of the source computer that's going to attach to it. Another thing that's just the only place I've seen it so far is in the cloud, is that you can, as an inbound rule on your firewall, say, hey, if the computer connecting to me is connecting to me from a known firewall of another name, I will take that as well. In addition to an IP address, I'll take that firewall's name as a valid rule for getting in. So we'll see both sides of this. So if I look at my EC2 instance and I go down to security, it is protected by a security group that I named it Dev Machine SG, and it also has some other unique identifiers associated with it. And this is its inbound rules. That's not really important. Um, we need to find the security group for the database. So let's go over here. And if I'm on the RDS page for this particular database instance, and I go down to connectivity and security, this one is called Database SG. And if I click on it, here it's listed again. Let me click on, well, all right, I'll just click that. And down here, down below, if I click on inbound rules, it says 3306 from the IP address that I'm using today on the public internet. But that's not the IP address of my EC2 instance or my container. So I'm going to click Edit Inbound Rules. And in addition to this incoming source rule, I will say also allow in port 3306 traffic, which is MySQL. And I will say instead of anywhere in the world, because then people could just brute force test usernames and passwords, I'm going to say let in stuff that's coming from my dev machine. So any EC2 instances and the containers running on them, protected by the dev machine SG security group, we'll let in that traffic as well. So I'm going to click save. And if I were to come out here and reload, it's still not going to work because it crashed. So we have to start it again. And now it should be running. And if I reload this, oh, something didn't work. Um, all right. Well, I'm gonna have to do some debugging here for a second. I don't know if I typed in something wrong. I'll find out what happened and come back and cross my fingers. Now, part of me is laughing because I just spent like 4 hours updating this tutorial the other day, and a couple days later, it's not working. But I'm going to do what any of you would do, which is I go out to AI and I say, hey, here's what happened. Can you tell me how I might fix this? And, I think I've actually seen this error before. Basically, it's saying that I used version 8.0 when I started RDS for MySQL, and it doesn't like the library I used in Node. And in short, it says uninstall MySQL, install MySQL 2, and then in my connection code, change from MySQL to MySQL 2, and I should be in good shape. That probably works. I can't believe that I just did this a couple days ago and it's changed since then. So at any rate, let's go ahead and give that a shot and see if I can get that working. So by the time you see this, I'll update it in the text document over here. So um, Let me go ahead and uninstall MySQL. There we go. npm install MySQL 2. And then I'm going to edit my document in Nano and make this relatively minor change. And I probably shouldn't do this in real time, but let's just see what happens. So now we do run the program again, hit reload. It works! Huzzah! That's probably the most exciting I've been all day because it was boring because this worked perfectly the other day and I had to like spend a couple hours doing this again for you. But having a problem and resolving it, now that gives me some endorphins and some excitement. This is like the most exciting thing that's happened to me all day is I ran into a bug and I fixed it while recording, which is terrifying. All right, so I will go back and fix that later. All right, in the meantime, let's continue on. Funny, funny. Okay, so we timed out, we've updated our firewall, things are showing up on the screen. Let's go ahead and update our code. Now, this is just printing out an array of information that was pulled directly from the database, so we're doing just a little bit more development. Also, I have a console.log statement in there for debugging, which affects the terminal, but it doesn't show up on the web page. So I actually print twice just for debugging purposes. So let's go ahead and update this again. And oh man, let's go ahead and I'm going to delete all this stuff that's the app.get. And I'm just going to make it so instead of just spitting out some text, I'm going to have it generate some HTML. And that will be right here. Cool. Anyway, you can read it. It's just updated stuff a little bit. Coming over to here, we hit refresh, and now it looks nicer. Okay, so I was talking before about the fact that what we want to do is basically create an application, typically create an application somehow with a container um, and once we get it to the point that we like it, we then want to package it up, save it so that we could launch unlimited copies from an image. So this is just development. When we're ready to go to production and push out, we save it as an image. So I'm going to hit Control C here, and we are now stopped. I will type Docker PS. Oops. Oh, I will type in exit because it says root at, so I'm still in the container. I'll do Docker PS and we can see that it is running. And we want to now turn this thing into an image. Just some information about it. Right now, has this ID and it has it slid off the side of the page here, but it has this name that was randomly assigned to it. So in order to create an image from this, one of the things we can do is do Docker commit, and just 1 second, it's a little noisy outside my door. I will hit pause. Okay, carrying on. As noted here, we do Docker commit, and then we can write the name, either the ID or the randomly generated name, and that will take my running container and turn it into an image. So Docker commit and do that, and it generates another ID. Now it looks similar in format to the previous one, but this one, instead of being a container ID, is an image ID. So if I do Docker images, these are like the programs that are now on my computer. And notice this one right here, it starts with E6EA. That is the same string that was generated when I did this. So in theory, I can start and stop this, or I could basically run lots of these. Okay. So this asks you what's your image ID, and let's go now. What we didn't though do is we didn't give it a super useful name. And so let's go ahead and take this thing that we just created and give it an actual useful name for when we need to run it in the future. So what we do is we do Docker tags. So notice right now it has no tag, like no good name. Docker tag, and then let's take this image ID space, and we will call this timekeeper app. All right, so now if we do Docker images, it gave that as the repository name, and the tag is the latest version of that. So in theory, we could have lots and lots of versions of our timekeeper app with different tag IDs. All right, so there it is. Okay, now let's go ahead and launch another one. Um, just one more time, let me just type something. So Docker PS, what I have running in real time right now is a container on port 80. Now let me launch another one and put it on 8081, but I'm going to launch it from my saved one. So I do Docker run detached interactive terminal 8081 port 3000. So it's going to be a completely separate one, and it's going to be launched from Timekeeper app. Oops, I've done something wrong. Timekeeper app. Did I not type that incorrectly? Docker. Oh, I have done this before. In fact, I did it the last time I practiced the lab. I forgot to type in the port. All right, so we're referring to a port. Now run it, and it's running. So I go Docker PS, and now we've got two things that are identical right now. One's running on 8080, one's running on 8081. Um, and there's a little question I ask here, which is if we hit this thing right now, would it run? Oh, I actually say do another one. Okay, so in addition to 8081, let's do 8082. So with a saved container called an image, with an image available, I can now just use that run command over and over again and just spin it up on different ports, 8081, 8082, and then it just shows up here in the list as things that keep getting launched. And even though it's a little hard to see here, we can see that the first one was launched from the image called node, and the subsequent ones were launched from the image called timekeeper app. Um, and so I ask a question now, do you think you could visit these containers from the web? And it's nuanced because even though the code's there, the answer is no in both cases, and the reasons why is different. On 8081, the container is there and it's up and running, but what we haven't done is we haven't gone onto that machine and typed node space index.js. We haven't started the application, so it's there. The code's there, but it's not running. And then on 8082, same thing, but notice how it's like continuing to spin there. What's different about that one is if you remember the firewall rule, we didn't open up 8082 as a potential place that you can connect from. So I'm saying here that I could go back and update our firewall rules, and we could go back in and start stuff. So let's go ahead and I guess I'll just go ahead and do that real quick. So let me see. So I go into I locate my EC2 instance, and I need to allow incoming traffic. I find the security group for it, which is security dev machine SG, and I'm going to edit the inbound rules. And so I'm allowing traffic in on 8080, 8081, but no 8082. So what I'm gonna do is I'm gonna get rid of that one, and I'll just say let in traffic from 8080 all the way through 8082, which is a range. Save that. And as that goes through, eventually this thing that was spinning is going to say, hey, I got through, but then the computer's not listening on, or anyway, there's no software running on port 3000 currently. And so I could fix that by, let's see, let's look for the 8082 one. I'll do Docker exec terminal interactive. It's called, oh boy, it's a long name. So I'm going to connect to that thing and I'm going to launch the program bash on there. And upon connecting, I look at what's there and there's an employees folder. So I go cd employees, I type ls, and then I do node index.js. And before I do that, notice this is a not functioning page. And when I run this and come back, and if I hit reload, this is awesome. So with just a minor start command, all of the code was retained when I launched this new container from my image, and all of the networking is set up to be able to talk to the database. Cool, cool. All right, there's something else we need to do next. Let's see. Oh, so something I could do to get away from the problem we just ran into. There's a couple different ways that you can make things start up automatically so that you don't have to log directly into them. So let me just let's find something here for a second. Docker PS, oops. Oh, I'm in the computer again, in the container again. Exit Docker PS. I'm gonna use that port 82. So I'm gonna say Docker stop and it's on 623C. So I'll just do 623C. So rather than typing that quizzical letterberg, I'll just refer to it that way. If I'd have been thinking, I would have maybe paused this lab halfway through so it's not so long for you. If you need to take a break, go out there and get a Taco Bell taco or something. Put some tasty sauce on there. All right, I'm going to run it again, and here's the command that I'm going to use. So the new feature here says, okay, it's the same as before. Docker run on port 8082 this image, um, but I want you to uh, run this command. So I have bash and then command. So saying when you start this, run the command from the command line, node space, and then the employees folder index.js. So if I start it that way, it started. And if I come out to here, and if all went well, this is technically going to be a new container, but it logged into the machine and it started things. So there's a couple different ways that you can do this kind of thing. Passing a command to the computer to the container so that it runs when the container starts up. This is not a preferred way, but it's just one way you could do it. I do this so there's kind of like an incremental progression in your knowledge. Usually what we want to do is when we create a container, we use something called a Docker file, which bakes in a whole bunch of special commands. And we can bake in this command right into our image if when we create our image, we use something called a Docker file, but that is for another lab. But that's just a preview of what's coming ahead. But if again, think about it. If you're spinning up 1,000 containers, you don't want to log into 1,000 containers to run this command. You need to just either pass this command into it when you are starting it, or bake that command for starting into the image that you're going to launch from. All right, so I talk about that process here, and Um, this I mentioned here that when you do this, there's technically for any container or image, there's already like some startup command built into it. This is technically not adding to it. This is technically overriding the one that was baked into it. All right, all right, incrementally messing with some stuff here. Let's go ahead and without using a Docker file, do the next incremental step, which is like baking it into the image itself. So I'm going to copy this command. And so notice that we Docker images. Notice that we have this image and this image. And then with the Docker commit command, remember that creates an image. This time, oh yeah, there's a couple things we got to change on here. So I want to, let's kind of go from left to right. Docker commit, and I'm saying in the image that we're working from, change the startup command from whatever it is to this. So I'm baking it into the image now. And the container that I want to update is the development one that I was working with. So that was on 8080. So here's my original development one. So basically take this container and we're going to call it new timekeeper app. We already have the other ones on here. I'm going to create a new one, and what's going to be different about this one is it has that startup command built into it. So uh, hit return. So if I do Docker images, we now have this one, and let's do Docker PS, and I'll do Docker stop, and I'm going to get rid of the one on port 8082 right now. It's got this name. So again, I could either use this ID or this name. Okay, I'm stopping it. And once it's going, and ooh, hey, we made it to the end of the lab. So if we can remember how to do this, Docker run detached interactive terminal port 8082 is attached to port 3000. And we're going to be running new timekeeper uh, app. All right, so this is building from everything that we've just learned, and hopefully I didn't mess up anything. And if I do Docker PS, 8082 is running something else. This time it's built from the new timekeeper app. So, and it had that startup command built into it. Let's just see if it worked properly. And it did. Okay, this has taken a ton of time, but you've learned a lot about how to interact with Docker, much more than just your basic stuff. Okay, now your to set you up for your next tutorial that I'll have for you at some point. Um, there's a couple things we can do. Well, okay, to set us up for the next lab, we can leave our RDS instance in place, I think. Let me just actually look through the directions here because there's tutorial one, two, and three. Maybe it's two and three that are tied together. We need a EC2 instance with Docker installed, so you can install basically your whole application, uninstall your whole application, all your images, etc. You will also need RDS and the data from this lab for your next lab. That's what I was looking for. Actually had it highlighted in red to know that it's important. So if you're going to be doing this other lab in the near future, remember 50 cents a day for RDS to be up. If you're going to take a long time, then you got to go to the first half of this lab again, recreate your VPC, your RDS, etc., put the data back in there again, and then do lab two. All right, but for us, let's go ahead and clean up what we can. And okay, so I'm gonna do three things. You can't like uninstall your images until the Docker containers are deleted. And you can't delete the Docker containers until the Docker's containers are stopped. And so if you search the web and ask for how to do those things, here is a command which will stop all of your Docker containers. So we do that. And then our three running Docker containers will go away eventually. Okay. Here's my next one. So now that they're stopped, I can now delete all of them. because they're technically taking up resources. So that actually got rid of like 7 stopped containers that we've been working with. So if I do Docker PS, nothing. Docker PS -a, nothing using. Docker images, and we still have these 3 things, and we can get rid of all of those as well. So this one, instead of RM, is RMI for remove image. Very creative idea there. Oh, how come I can't? Okay, let me try this one more time. Okay, Docker remove images. Okay, so everything's gone now. RDS is still running. This thing has Docker installed, um, but there's no containers images on here anymore. It's just an EC2 instance with Docker installed, and it's got some good firewall rules. For being able to visit 8080 through 8082 on here. So we'll pick up from here in the next tutorial where we will learn about cool new things, including, I believe we'll be using Dockerfile next. So thank you for sticking with me and see ya on the other side.